Hey guys, I'm Daniel. I'm going to be showing you how to find a the time it takes for a certain reaction to reach a certain completion rate. All right. So the question we have here is a certain reaction A yields products is second order in A. If this reaction is 10% complete after 20 seconds, how long would it take for the reaction to be 90% complete? Okay. So the first thing to realize here is that we're pretty much talking about two separate reactions. Okay, first of all, we're first talking about a certain reaction reaching 10% completion, but it wants us to find the time it takes for it to reach 90% completion. All right, so we're going to be using the same rate constant to find the time for the second reaction, which is 90%. Okay, so the first thing we do here is to kind of identify some artificial values. Okay, since we're not given any certain concentration to begin with, we're going to be assuming that we're starting off with the 100 molars of something. Okay, so let's identify A naught as 100 molars. And in the first reaction, we're reaching 10% completion. So the final concentration is not going to be 10. It's going to be 90. Just in case that might be a little bit confusing. So 90 molars is our final concentration, and the time for the first reaction, T1, is equal to 20 seconds. Okay, so we're going to be using these values to try to find our rate constant so that we can apply it to the second reaction in which it reaches a 90% completion rate. So anyways, let's go ahead and start plugging things in. Alright, so our reaction, we're using this second order equation right here, and we plug in our final concentration, which is 1 over 90, and I'm going to go ahead and move this to the other side of the equation, so it'll be 1 over 90 minus 1 over 100. Okay, and that's going to be equal to K times T. Alright, so allow me to plug that into my calculator, and 1 over 90 minus 1 over 100 is equal to 1.1111 times 10 to negative 3. Alright, and that's going to be molars to the negative 1 equals K times T. Alright, actually let me fill in the value for T, which is 20 seconds. And we're going to move this 20 seconds to the other side to isolate our K. Alright, so we have 20 seconds over here. So 1.111 times 10 to negative 3 divided by 20 seconds gives us 5.56. So 5.56 times 10 to the negative 5. And that's molars to the negative 1, seconds to the negative 1, is equal to K. Okay, so we're going to use that rate constant to find how long it takes for the same reaction to reach 90% completion. Okay? So if you haven't written all this down yet, I don't know if you want to write it down, but I'm going to be erasing, so please pause now if you want to get that. Alright, so let me erase this. And this as well. Alright. So now, our values are going to be changing a little bit. Alright. So in the second reaction, we are going to be reaching a 90% completion rate. And if you think to yourself, what should be our final concentration of A? Alright, and if you kind of try to reason that out, it should be 10 molars. Alright, so 10 molars, actually that's kind of 10 molars. That's our final concentration in our second reaction because it's 90% complete. Alright, so, and we carry this K over here, so K is equal to 5.56 times 10 to negative 5 molars to the negative 1, seconds to the negative 1. So 10 to the negative 5 molars, negative 1, seconds, negative 1. Alright. Let me go ahead and erase this value down here for space purposes. And now, let me write our new equation. Alright, so we start off with 1 over the final concentration of A, which is 10 molars. And I'm going to go ahead and move this over here before I do anything else. So 1 over 100 as well. equals K, which is 5.56 times 10 to the negative 5 molars to negative 1 seconds to negative 1 times T. Alright, so I'm going to be, actually let me plug that into my calculator. I'll take it one step at a time. So 1 over 10 minus 1 over 100 gives us 0.09. Okay, so 0.09 is equal to our, I'm just going to bring that down, our 5.56 times 10 to the negative 5 times T. Alright, so now let's divide our K by this. Alright, I hope I'm not confusing you. We're still bringing this K value down here and dividing it by 0.09. So I hope that's not too confusing. So 0.09 divided by 5.56 times 10 to the negative 5 gives us a value of 1,618.7. So that is our seconds, or our time. So T right here is going to be equal to 1,618.7 seconds. And the problem set that I'm actually using here says the answer is 1,600 seconds, which is just an approximation. So it's approximately equal to 1,600 seconds equals T. Alright. Now I hope all of that kind of made some sense to you. Hopefully you were able to follow along for the most part. And thanks for watching. I hope you enjoyed.